This video I'm going to do is on the test and the edit features, which are these two down here. Now so far these have really been neglected a little bit, and there's no documentation as yet because I haven't had a chance to write something up about them. So I thought I'd do a video on them because some people have been asking about how to use them. So what we'll do is, I've got a Pengo board powered up at the moment, and I'm going to show you how to create a test sequence using this with a couple of tests in it, and we'll see how we get on. So to create a test sequence you have to use the edit, which is that one. So you click that and it's opened up at the top. I'll bring the window back down. There it is there. Now obviously if you've got it on the LCD it will just overlap anyway, so you'll only get one screen at a time. So that's the test edit screen, which allows you to create a test sequence and edit a test sequence. So the first thing we'll do is we need to give it a name, and it's case sensitive, so what we'll do is we'll set it to, we'll change that back to capitals and type in Pengo, which will be the name of our test sequence. So it will rename it as pengo.tst in the test programs folder on your desktop screen. So that's it. So we've got that. Now the first thing we need to do is start putting some tests into it. If we did load, nothing will happen, okay, because we haven't got anything there at the moment. So the first thing is, there's two types. There's a type M and there's a type S. M is for measurement and S for special functions. We'll leave it at M for the moment. Its default is M. And the device is the name of the device. So if we go, I'm going to find a chip on the board, which is quite useful, which will give us some signals. So we're going to use an IC66. Okay, that's the device on the board. So we type in IC66. And then what we need to do is the pin number. So if you want to test a particular pin, let's go for pin 7, 8, 9, 10, 12. Pin 12 we're going to use on this example here, so we'll put pin 12. And now what we need to do is reference all the data. So because it's a measurement, we just put a reference in. So it's going to be a 74 LS74. Okay. Now debug info allows you to type whatever you want in within that box. So if the test fails, the debug information will be displayed, etc. So it could help you locate the fault. So you could say, if it fails, it could say bad, or we could say check, I don't know, IC50 for example. Anything like that. You can put some information in that will help you if you get a fail. Now you don't do anything with these boxes down here. What you now need to do is, you could do two different things. You could actually just click append, which adds the test in. Append is always used to add a new test in. So if you did append, you'll see we'll get the test go up the top. Now it has got defaults with the high and low limits, and the tolerance is 15%, so it will set that. And you can see here the tolerance is default at 15%. However, what we'll want to do is we want to measure it, because if we leave it at that, it will naturally fail. So you select the test and you edit the test, and the information you've typed in will come back down the bottom and it will put high and low limits in. Now those obviously have been stored by the tester. So what we'll do is we'll measure it now. So if we go to the pin, and you have to hold the probe on the pin while you do this, and then you do execute test, and you'll see you'll get a figure 49.8. Now this is duty cycle it's measuring here. And it's showing it as green because it's passed it, but it will pass it when you do edit test here, because what it will do is it will adjust these two limits to suit that. So it will center the measured value between the two limits plus or minus 15%. Okay, so we're quite happy with that. So we'll replace that test. Because we already have it in the list, you need to replace it. And that's it. So that's that test stored. Let's do another one. So now what we need to do is another chip. I'll find another one. We'll do the same again, IC66, because that seems to be quite a good chip. This is in the video circuit, so there seems to be quite a few signals flying around here. And this time we're going to use pin 9, and it's a 74 LS 74, and debug information we say check, we can say check clock for example, I'll spell it right, and I'm going to, this is a new test which you're going to add in here, but the first time we put it in there and then brought it back down and executed it. This time what I'm going to do is I'm just going to execute it. Okay, and you can see this time it's read 92.3, and you can see it's set the limits accordingly again. So we'll then append it, and we now have the two tests. Every time you append, it puts the test below the last one you've put in, and it will just keep building up a file like that. If you want to edit the first one, you do edit, and you can see the information is brought back. If you want to edit that one, it brings back that. So this is how you build up a test sequence using that. Now we'll do one more. What we'll do, if you do clear, clear starts you afresh down the bottom. So we'll do IC66 again, and we'll do pin 7 this time, which, as you will know, pin 7 is a ground pin. I'm just putting this information in, obviously, and it keeps you correct. You can obviously get all this information off a schematic as well, and you can say ground bad for example. Okay, we probe that and execute it. You can see it's measured 0, it's set, the high limit is 100, the low limit is 79, but when we append that, you can see it's stored it in there and it's set the low limit to low. These limits down here, don't pay too much attention to these when you're actually editing, when you're executing the test, because it is measuring it and storing it. So if you go back and edit that, you can see it's set the high and low to 0, and the measured value is obviously not there. But if I execute it, it'll come back to 0, and it's green because it's passed. If it comes back red, it will fail it. If you have any tolerance problems, you can actually, if you find it's very sensitive to slight changes, you can change the tolerance, execute it, change the tolerance, and then replace it again. We won't do any of the other features at the moment on that. We'll just close that one down. So we now have three pins of one device stored as a test sequence. If I now go into the test screen, bring that one back down. The test screen allows you to execute all the tests. It won't let you edit the tests or change them. It will only let you execute them. There's different ways you can do this. So first of all, we need to type in the file we want to run, which is just Pengo, and we load it. And you can see it tells me I've got 3 tests in there, and that's the ones we've just stored. You can see it's a type measurement, IC66 12, 9 and 7, and it tells you the device. And it says select test above, and that's the information you get. There's 2 ways of doing this. If you did a single test, you need to select a test. So for example, we do, say that one, do single, please probe 74 LS74 pin 9. So it will tell us to do that. So we're going to do that. And it's passed it, as you can see. It tells you the high and low limits, and it tells you the measured value. You can do that with any of them. So if we do that one again, that one, it will say pin 7, so we'll measure pin 7. And it's passed it again, it's measured 0%, which is correct because it is a ground pin. Now, the other thing you can do is the auto test. If you click that, what it will do is it will work its way through the whole test sequence. So pin 12, it's asked me to probe. Failed that one. It's maybe because I've gone and probed the wrong pin on the wrong chip. So there you go. So it's obviously failed it. That's fine. We'll let it carry on. So now it's telling me to pin 9 of IC66. We'll get it right this time. Passed it. On to the next one. Pin 7. And it's passed that, but it's come up fail because we have one fail. When it fails it, the information, including debug information and all the fail results, will be put into a text file. Okay, so if we do the auto test again, and I actually probe it right this time, pin 12, you'll see it will come up pass hopefully. 10, 12. That one's worked. Now it's wanting me to pin 9. Now if you hold the probe on, it says release probe. As soon as you release the probe, it knows and it will move on to the next one. So it can only go at a certain speed. Pin 7. And that one there's passed all 3 and it says pass. And that's basically how you create a test sequence and you run a test sequence. So you can create whatever you like. So you could work your way through, say, the Pengo board or the schematics, and you can sort of work out a test sequence. So if you then have a good Pengo board, you can do all that with it. And then if you have a bad Pengo board of the same type, you can then load it in and run through the test sequence, and it will ask you to probe, and it might give you information as to what's failing. So rather than you going through the schematic trying to figure it all out, you can actually get this to run, and then it will probe all the various signals that you want to check, and if any of them fail, it will give you an idea. So it saves you having to poke around checking for enable signals and whatever else. The other thing we can do is if we go back to that, what I'll do is I'm going to stop this video and I'm going to start a new one, and we'll go back in and I'll show you, when I bring this screen back down again, I'll show you how to delete and insert. Okay.